Alright, so there are two things we're going to talk about this week in calculus. It's going to involve finding limits in a more mathematical sense, so that means that we're going to be using our graphing calculator. The title today is Finding a Limit Using Graphs. So this is one way that we can determine the limits by looking at what happens on the graph. So you need to get your calculators warmed up. If you need to stop the recorder at this point, go ahead and then continue on when you get your calculator out ready to go. Alright, before we actually start doing the calculations, we need to focus on the theorems of limits. So return to your book on page 59. Towards the top, you see theorem 1.1, some basic limits. There are going to be rules for determining limits. Now, what I'm going to expect you to do is not memorize all these rules. I expect you to be able to use them. So you're going to make a sheet of theorems throughout this class. And we're going to put those theorems there that you will be allowed to use on any quizzes. Okay? Make sure you include all the aspects of any theorems that you put on your calculus toolbox, is what we're going to call that. So pause here to start that calculus toolbox. When you have completed that, start the video again. Okay? So go ahead and pause it. Okay. Now, this is actually going to be fairly simple, but you're going to have to understand how your graphing calculator works. So I have an 84 here. And what you need to do is we're going to look at examples of how this is going to be used. Okay, so let's just take let's take a look at problem number 1 and see how we would use that and how it translates into one of the three parts of the basic theorems for finding limits. Okay, so let's take a look at the graph of f of x equals 5x squared minus 5x. In this particular case, x is going to approach 5. We want to see what is the absolute limit is of this graph at that particular point. So instead of doing the mathematics, which you can probably see what the limit's going to be if you did the mathematics, we need to prove it on the graph. So you're going to punch out on y equals, go to the upper left-hand part of your key here, of your screen, or your board rather, on lower left-hand part of your screen, hit y equals, and then punch in 5, then you have this button here, xt, theta, and n, hit that to hit the x, then hit the x squared button, get the square in there, minus 5x. But don't hit graph, just get that calculation in. Now, you might already have this in there, but what you need to do is go to Zoom, and you're going to see it number 6, Z standard. Okay? So at Z standard, you're going to hit for that Z standard. That means you're going to go to the standard window, and we'll talk about window in just a little bit in case you've forgotten or never knew how to do that. When you hit that, it will automatically graph using the standard numbers for x and y. X being negative 10 to positive 10, y being negative 10 to positive 10, and every line on there represents a 1. Okay, so you hit the 6 for the zoom, and you're going to see a parabola form. Now, when you see something clearly what the answer is going to be, you don't have to do any real finagling around with the tracer button or any kind of extra zooms. We'll do that in the second part. But you can tell that the graph is going to hit x equals 5 at 0 for y. So in this case, the limit equals 0. And we use capital L to describe the limit. It's that simple. Now, what happens if it's not that simple? Well, Let's take a look at the next part, in which we're trying to find the limit for the next problem. The other problem is exactly the same thing. We're trying, well, actually, let's do the second part here. This is the limit at x equals negative 1. Okay? So at x equals negative 1. That's not so clear. That's not so clear. So what you're going to do is you're going to hit the trace button. And mine pops up at 0, 0. Now I want to go to where x is negative 1. So I'm going to move that trace button by hitting the left arrow. So it's going to keep going left and left and left, which is technically going to be up and up and up. But the value of x is going to decrease as we go along here. We have negative 2.12, negative 0.425, negative 0.638, negative 8.51, and negative 1.06. So the two spots that go around negative 1 are negative 1.06 and negative 0.85. Well, negative 0.85 is about 0.15 away from negative 1, and negative 1.06 is 0.06 away, so that's the closer of the two. So that's what we're going to focus on for the next step. Okay? At that point, then, now you're going to hit the zoom button again. But what we're going to do is we're going to zoom right into that area, and it's going to create a new window on its own to accommodate a change. I forget exactly the dynamics. I want to say it's either 3 or 5 times closer, but I'm not 100% sure on that. Regardless, it's going to get closer, and it's going to be a different looking graph than what we saw there. So hit 2 for zoom in, and then hit enter. And you will see the y-axis, but you don't see the x-axis anymore, because it's focusing in just that small area that we had our little tracer on. So now we're going to hit trace again. And again, we start at negative 1.06, but now, since I went negative 1, I'm going to go down or more to the right. So I'm going to hit the right arrow, and that's negative 1.01, and that's negative 9.57, so negative 1.01 is really close. And you can see it's going to be probably going to be positive 6, but we want to get a little bit more precise. We'd like to get 1.00 on the calculator when rounded off, and then we can round off the value of y and see if it coordinates with it. So we're going to hit zoom again. We're going to hit zoom standard, no, not zoom standard, I'm sorry, zoom in. So we're going to hit 2, and now we're going to hit enter. And now the y-axis completely disappears, so we kept getting closer and closer. You do see a little dot in there blinking, but that's not the tracer. You need to hit the tracer button when you got that. So you hit trace. I got negative 1.01, so that's a little bit to the left of what we want. So we want negative 1.00. And then we get negative 0.997. So we got negative 1.00, which is 0.01 away, and negative 0.997, which is 0.003 away from where we went. So we're getting really close, but we still don't have negative 1.00. But you can see y is definitely going to be 5.98. You probably could stop at this point and say, definitely this is going to be 6, but let's just be 100% sure. So let's hit zoom in, trace. I messed up. I should have hit the trace, then the zoom in. Let's see what happens. I think we're going to be good. We'll see here. Nope. It doesn't get any closer. At least I probably hit the wrong order. That might have messed it up. So if you did the order that you should have done, which is hit trace and then zoom in, it might have worked properly. But regardless, you keep going until you get negative 1.00 or as close as you can possibly get. Look at the value of y, and this is going to be a limit of 6. Okay? So that's how you do that. Now, let's take a look at number 3, which deals with a cosine function. Now, this is kind of interesting. So, this is number 1, and we're going to take a look at number 3.